Here we go. All right, here we are. We are doing lesson 50 in Algebra 2, and it's finding inverses of relations and functions. Let's first review, what is so funny? Let's first review what a function and a relation are. Does anyone remember what function is versus relation? Everyone's afraid to speak because it's going to be on YouTube.
No, I don't remember.
Okay, here's a hint. Vertical line test.
If it passes it, it's a function. If it doesn't, it's a relation.
Okay. All sets of number pairs are relations. Some of them are functions, some of them are just relations. So let's start by reading on page 355. Tabitha, will you read that?
A relation is a set of ordered pairs. If R represents a relation, then the inverse relation is the set of ordered pairs obtained by reversing the coordinates in each ordered pair of R. So if AB is in relation R, then BA is in the inverse relation. The inverse of a relation may or may not be a function. If a relation and its inverse are both functions, they are inverse functions.
Okay, anybody want to translate? If I have a point AB, what is the inverse? BA. Okay, so here we have example 1, and I went ahead and graphed it. These are my ordered pairs. Just for fun's sake, is this a function? Is this relation a function?
No.
No, why not?
It has two ones in the next thing.
Yeah, and the ones they have different partners, so you can't do that. And you can see here that the vertical line test, it would not pass the vertical line test. So if this is my ordered pair, these are my ordered pairs, what would the inverse of that set be, of that relation be?
2, 1.
2, 1.
4, 1, 5, 3.
4, 1, 5, 3. So we're just switching those. Easy enough, right? Okay, let's go ahead and graph those. 2, 1, 4, 1, and 5, 3. 5, 3. Can anyone see a pattern between those?
Yes.
What pattern do you see?
It's like,
It's an inverse.
Yeah, okay. If I
yeah,
drew,
it's like a mirror.
does that help? If I drew the line y equals x, does that help with the pattern?
It looks like a mirror.
A mirror, which is also a reflection. It is a reflection over the line of y equals x. So that is how, if you graph it, that's how you know it's the inverse as well. Okay, so is the inverse a function?
Yes.
Yes. How do you know?
Because
It's
Yeah, it passes the vertical line test. So a relation, if it's not an inverse, if it's not a function, the inverse could be a function. Okay? Yes.
The vertical line test again.
Vertical line test. If I have, this is my, let's say, that's my function. If it only passes through the function one time with the vertical line. If it's like this, that passes twice. One line passes through it twice, and so that is not a function.
What if it's
Like this.
the other way? Oh wait, yeah. Oh, okay.
Yeah. Okay. All right. So I erased my boundaries. That's not good. Going on to horizontal vertical line test. We talked about the vertical line test. The horizontal line test is going to tell you if it's a one-to-one function. So vertical line test is if it's a function. If it passes the horizontal line test, which is the same thing but with horizontal lines, then you know it's a one-to-one function. And we're going to get to that in a minute. Look on page 356. If we want to find the inverse we want to find the inverse of this function. I don't have points this time, so I can't just switch them. But what can I do with this?
you can
Put in y equals mx plus b.
Yeah, it is in y equals mx plus b. This is what you can do. You're going to switch the x and the y.
That's inverse?
And then you're going to solve for y. And that is the inverse.
Can't you just solve for y and then name it x?
You could solve for x and then switch them. You're going to get the same thing. This is the inverse. Okay? Does that make sense? Question?
Oh, I see it.
Okay. Look under that example on page 356. It says the vertical line test determines whether a relation is a function, but it also leads to a horizontal line test to determine whether the inverse is a relation of a function. So what that means is the same thing as a one-to-one function. So we'll go on to lesson 3. Example 3. Find an example of an equation of the inverse y equals 1/4 x cubed minus 2. It says using a graphing calculator, which you can use, and the vertical and horizontal line test determine whether each relation is a function. If you have a graphing calculator, go ahead and graph that. It's going to look something like, but you can see in the book. Yes. It's going to go kind of like that. So let's go ahead and find the inverse of this function, just based on what we did before. What's the first thing you do?
Switch the x and the y.
Switch the x and y. So go ahead and do that.
Does the cubed unit thingy go with the x?
Yeah.
Yes, not with the 1/4. Was that your question?
No.
Oh.
When you switch the y and x, are you just switching the actual
Oh
letters?
no, just switch the y and the x. So, oops. And then what are you going to do? Solve for y,
Got it.
right? Okay. To determine if this is a function and the inverse is a function, you can do the vertical and the horizontal line test. So vertical line test, is this a function?
No.
No.
Yeah?
Yes.
Kind of hard to tell, but this ever so slightly heads this way. It heads this way as it heads that way. And this ever so slightly. This looks like it's horizontal, but it's just very slowly decreasing. And on a graphing calculator, you'll be able to see that using the graph and trace functions, which I can show you. But so assuming that this is not this is not horizontal and this is not vertical, it's ever so slightly headed this way, is this a function?
Yes.
Yeah.
Okay, horizontal line test. Is the inverse a function?
Yeah.
Yes, because this looks horizontal,
Oh, but it's not.
but it's really not.
Oh.
Doesn't matter if it's flat.
Okay, it's really not. So that's how you use the horizontal and vertical line tests. One more example. Look on page 357 at the top, and Jamani, will you read that?
The inverse relations in example 3 are inverse functions, and the domain and range of both functions is a set of all real numbers. In some cases, an inverse is not a function, but a domain can be restricted to make it a function. The inverse of a function f is denoted f-1.
Okay, so, and this is, believe it or not, kind of getting into some stuff that we did in pre-calculus this year. If they, all they're saying is if I have, something like, oh, that's not a good idea. Okay, say that's my graph, okay? Is it a function?
Yes.
Is the inverse a function?
Yes.
Horizontal line test, no, because that clearly goes through there. Can I restrict the domain, which is the set of x's, to make it a horizontal, to make it pass the horizontal line test? If I go from here to here,
I don't know. Yes.
Oh, I see.
Oh, I understand.
okay, so I could say from, if the domain is x is, between -3 and 3, then it passes the horizontal line test. And that's all it's talking about there, restricting the domain. So that is the lesson, a lot simpler, I hope, a lot shorter than yesterday. And we are going to start.